All right, here we go. Problem number 1. We're getting off on the right foot here on number 1. All right, still going to use some sine, cosine, tangent. Yep, we're traveling to our boy's house here, Big Al. All right, you even see his house up there too. Yep, Big Al's house is up there. Yep. All right. This is from last year. We just changed it this year to be Big Al, so don't mind. It used to be Janeth, but we kicked Janeth out of the house because Big Al rolls big, as you can see. All right, so we kicked him out of the house. All right, so now it's Big Al's house. All right. So here we go. Here we go. The bus drops off at the corner of H and First. So H and First, we're dropping them off there. We walk approximately 300 feet to the school. You plan to walk to your friend Big Al's house after school to work on the project. How many feet are you going to have to walk from school to Big Al's house? All right. So if you take a look, hey, just take a look at the triangle. Let's go. I want to go through everything here. What side am I solving for here if I'm going from the school to Big Al's? The hypotenuse. All right. So I'm solving for the hypotenuse length. I still want to go through every option we have in this unit. Pythag. Why not? I don't have enough sides. 30, 60, 45, 45. Nope. Hill-Sass? No, because I don't have n. Altitude to the hypotenuse, so I can't use Hill-Sass here, but I can use what I showed you yesterday, which is sine, cosine, tangent. All right, what acute angle am I given? 41 degrees. So let's focus on 41. Label the sides I have given you from 41. All right, don't yell anything out, but what's the distance I need to walk, and then what's the 300 acting as? Okay, so what sides do you have? 11, what sides do you have? We have the opposite and the hypotenuse. And yesterday, all right, we met SOHCAHTOA, which, by the way, anybody do any little Googling on that last night? Totally false, but you guys ate it up. Totally false. I've never even seen the movie Pocahontas. All right. That's news to me. Sorry. We're really in the Doc McStuffins camp right now. Doc McStuffins, yep. Mickey's Roadster Racers. Yep, that's any princess one, yep. Mm-hmm. She's so cute. Yep. Okay, moving on. All right, now that I know the opposite and the hypotenuse, 7, which ratio can I use? If I know the opposite and the hypotenuse. Sine ratio, yep. So sine, abbreviated SIN. What angle are we going from? 41. So the sine of 41 is going to be equal to opposite over hypotenuse. What's that ratio going to look like before I solve it? 5? 300 over x. We did a ton of these for homework and yesterday in class. Make it into a proportion and cross multiply. So sine of 41 times x will be equal to 300. How do I get x by itself? Here we go, 20. How do I get x by itself? You got it. Divide by the sine of 41. If you have a new calculator or borrowing somebody's, please make sure it's in degree mode. So how far, and then let's start paying attention to rounding directions here, nearest foot. How far are you going to have to walk to get to Big Al's house? 12? Yep. 457 feet. It's worth it. Okay. Could have been 4,057 feet. We're still going. Okay. Questions for you guys? We okay? Because I'm going to step it up now in the next couple. All right, next one. Now we're on a ship. We're going to sail 27 degrees northeast. So go in this direction from here to here, northeast. We go 120 miles and then, guy is silly. He realizes he made a mistake and he was supposed to go directly east instead of northeast. One job, right? One job, shipmate. So he's here now. He went, and then he realized, hey, I went in the wrong direction. I got to go directly east. How many more miles south does he have to go before he reaches his destination? So does everyone see what we're looking at to solve? All right, so we're going to solve for this leg of the right triangle, directly south. How far does he have to go? All right, help me out. What sides am I given? Here we go, 20. What sides am I given? Hypotenuse and the opposite side. Yep. All right, so ratio I need to use. Hearing from everyone. I love it. 17. Sine. Yep. Sine of, what's my acute angle, everyone? 27. Equals, what do you got for opposite and hypotenuse? 14. Okay, that's hypotenuse. Opposite. Just x. Yep, x over 120. Everyone all right setting? Are we doing all right setting them up? Somebody asked in my first period class, does the order matter? You're darn right it matters. It's opposite over hypotenuse. All right, it's never hypotenuse over opposite. All right, cross them up. X will be equal to 120 times the sine of 27. And what's it asking for? Round your answer to the nearest mile. Mile. So nearest mile, 12. What? Go ahead. Go. Let's 120 times the sine of 27, round it to the nearest mile. 54 miles. We okay? No? Everyone all right before I move on? Because this is a typical Regent situation now where you found one part of it, now it's going to ask you as a secondary one. Everyone all right? Okay, what's the next part asking us? Well, how many extra miles did he travel instead of just going directly east? Ooh. All right, how many extra miles did he travel going northeast and south versus just going east? All right, well, help me out. What do I still need to find then? I still need to find if he went directly east, how many miles he would have gone. So let's talk here. Let's make a decision. I'm going to call on somebody. We won't make a class decision. How could I find that third side? Because you already know the two of them. How could I find that third side, which is adjacent to the 27? So you could really use anything that's got adjacent in it. Or you could use another way. It's up to you, but let's find out. You're going to decide number 9. Okay. He's going to do a Pythag out of the ordinary. I like it. What else, other than Pythag, what else could I use that has adjacent in it? Tangent and cosine. Okay, I could have used either one. Hey, you decide what you want to do, though. All right, Justin and I will do a little Pythag, though. You decide what you want to do. So what's Pythag going to look like, Justin? Okay, so a squared plus 54 squared equals 120 squared. All right. So a squared equals, let's move everything over. Here's what I'm getting, 11,484 when I move everything over. I take the square root of that. When I take the square root, when you guys find this side, however you did it, cosine, tangent, or Pythagorean theorem, are we done with the problem? No. Why did I ask that? Because I don't want you to do what to this number here? Round it. We're not ready to round anything yet. So I'm going to say that side is, and again, we may have different values here. 163, 4266. If you got a different value, that's fine. It's because you decided to use cosine or tangent versus Pythag. And you may get a different value. That's fine. Because here's why. Because what did we do up here? What's that 54? Is that really what I got? That side is 54? No, it's a rounded answer. Okay, that's why. Because I'm using a rounded answer in Pythag. You're using a rounded answer in cosine or tangent. If we all use that full decimal that we got before we rounded it, we all be on the same page now. Good? All right. So now I need someone to explain to me, hey, how do I find those extra miles then? We know that side is 107.1 or whatever you have by doing cosine or tangent. How do I find the extra miles then? Evan, go ahead. Okay, so what am I adding? How many miles did I go in the wrong direction? I went 120 plus the 54 in the wrong direction minus what I just found for that leg, which for me would have been the 107.1634266. Are we okay there? How many extra miles? All right, now, and Amy, this goes back to your point. We may be different by 1 mile here. I'm just letting everyone know that depending on how you found that third side, we may be off by a mile, you and I, and that's fine. All right. So what do we end up here? I end up with 67 miles. Anybody end up with 68? Because that's still correct. You didn't do Pythag, right? Okay, there we go. All right, you could have 67 or 68. Again, it's because we used a rounded answer in our calculations, which is, they didn't ask to do that, so we're fine. Take a breather, ask away here, because this next one is going up a level or two right now in difficulty. Anything? All right, here you go. I'll just let you read through it. Find the third side. We run into a problem right away. What's our problem? Everything we did this unit has to involve right triangles. Is there one up there? Okay, but I'm still asking for that third side, though. That's just showing you the angles. So that one's 99. They're not congruent. Any thoughts here? Because I really just don't want to go up there and tell you how to do it. I want to think this over. Let me repeat what I just said. Everything we've used this unit, you needed A? Okay. Well, let's build off that. I can't make the whole thing a right triangle. So let's use our big girl words. Thank you. Make an altitude. Correct. Everyone see what's an altitude do? Forms a right angle, right? So let's draw an altitude down from that 99 degrees. And before some of you get crazy, is this an isosceles or equilateral triangle? No. So it does not split that in half. Don't go there. It only splits it in half if this whole triangle is isosceles or equilateral, which it's not. All right, I got it right. I got right triangles now. Do you have more suggestions for me how I can find this whole side? Because you got right triangles now. How can I still find the whole side? Hugh? Sine? You sure? Because sine is opposite, and that would be that side. So here's what he was saying. Find that side. Find that side. And do what with them at the end? Add them up. Okay, so you're going to take that right triangle on the left. What's the 4.04 acting as? Hypotenuse, thanks. And how about the x? That's adjacent. You good there, Will? All right, could barely see over there. All right, adjacent and hypotenuse, good? Anybody else? No, nobody else picked that up. All right, never mind. Cam. Thanks, Cam. It's Cam. Oh, good. Yep, I got Rambo over here. Yep. Go ahead, Cam. Well, you wouldn't use cosine to find the altitude because the altitude is opposite. You'd use sine, and then, yes, you could use Pythag. Yes, twice. All right. Yes, you could. All right, I'm going to use cosine on both of them, so I'll let you guys go ahead. Find x and y and add them together and round to the nearest hundredth. Remember, don't round anything to the end. So keep those two side lengths full decimals. We'll see if we can come up with the same result. Full side to the nearest hundredth, 6.00. Yep, and there are no units on here, correct? Anything you want to talk about? We didn't get 6.00, adding the two together by doing cosine twice, or sine and Pythagorean theorem twice. You would have to use that full number you got for the altitude. Yes, don't round it. Use that full number for B or A. Yep. Okay, we got one more here. Rectangle. Ooh, okay. All right, I see you, rectangle. Here you go. There should be a plural there, diagonals of a rectangle, because we are going to talk about two of them. Both diagonals measure 22. And that makes sense. Anybody remember that property about diagonals of a rectangle? They are congruent. Yep, so that makes sense that they're both 22, the same length. And they intersect at an angle whose measure is 110. So both diagonals intersect at an angle of 110. And that 110 could go anywhere. I'm just going to make it the one that looks obtuse there. 110. What's the length and the width? What else do you know about a rectangle that might help us out specifically in the unit we're in? All the angles are right angles. Do the diagonals make right angles? No, that's called a rhombus. But I do have right angles at all four vertices. All right. Do you guys see right triangles now that maybe I could use? All right. So what I'm going to do right now, I'm going to highlight the right triangle that's got X and Y in it for me. So this one right here. Can I use Pythag? No. Hills and Sass? No. 30, 60, 45, 45? Nope. Sine, cosine, tangent? Not yet. Is that 110 in this triangle? No. I need your help right now. Can you find me this angle right here or this angle up here so I can do sine, cosine, tangent? And we're going to have to get out our properties of a rectangle. Anybody go from the 110? Anything else you could fill in for me? Sure.
Well, the one up in the top right would be 35.
Oh, you think so? What are you using about a rectangle that you remember?
The diagonals of a rectangle intersect with 4 isosceles triangles.
Remember that one? It's not bad, stud. Not bad. Not bad. The diagonals make 4 isosceles triangles, and what's across from those congruent sides? Congruent angles. So if that's 110, you guys have 70 degrees left over. Divided evenly by 2 would give me, Sean, again, 35 degrees here. So do you guys see, in this right triangle right now, I'll draw it out. We got the right angle. We got 35. Trying to find those two sides. Whoa! Don't I need to know a side to do sine, cosine, tangent? Do I? What is it? The diagonal. The diagonal. 22. So it's up to you right now. Go ahead and find x and y using sine, cosine, tangent. Pythagorean theorem for the second one, whatever you prefer. So you decide. You decide what you want to use. Got to find x and y because that'll be our length and our width. And nearest integer, which means whole number, folks, whole number. Make sure 13, 18. Then if you do get 13 and 18, feel free to flip her over and get going, see how much you can get done with the first problem there.